Welcome back. Lesson 17, Permutations and Combinations. Introduction. A permutation of a set of distinct objects is an ordered arrangement of these objects. An ordered arrangement of R elements of a set is called an R permutation. For example, in how many ways can you make a group of 7 children stand in a line? Tells me to ask the 7 children to stand in a line. That means order matters. Who is first? Who is second? That matters. So, you have 7 children. First place, there are 7 options. Once a choice is made, second place, there are 6 options. Third place, there are 5 options, and so on until 7th place is exactly 1 option left. So total ways of making a group of 7 children to stand in a line is 7 times 6 times 5 times 4 times 3, 2, 1, which is 7 factorial, that is 5040 ways. In how many ways can you get 5 children out of 7 to stand in a line? Again, this tells me order is important, but I need only 5 children. So, getting the first place, there are 7 options. Second place, 6 options. Third place, 5 options. Fourth place, 4 options. Fifth place, 3 options, and that's it because we have only 5 choices, 5 to choose. So total ways of making a group of 5 children out of 7 children to stand in a line is 7 times 6 times 5 times 4 times 3, which is 2520. The number of R permutations of a set with n elements, it's denoted by PNR. This is permutation of R permutations from n objects. So what is PNR? It is n times n minus 1 times n minus 2 all the way n minus r plus 1. So if n is a positive integer and r is an integer from 1 to n, then there are PNR R permutations of a set with n distinct elements. Theorem 2. If n and r are integers where r is between 0 and 1, then PNR is n factorial over n minus r factorial. This is easy to see. N factorial means n times n minus 1 all the way until 1. So some things got cancelled. That something is precisely n minus r factorial. Here is another example. In how many ways can you select a chair, a deputy chair, and a secretary in a department of 35 members when no person can hold 2 positions? Well, you are selecting a chair, a deputy chair, and a secretary. No person can hold 2 positions. Start with the chair. Number of choices for the chair's position, 35. Number of choices for the deputy chair's position is 34 because 1 person is chosen here. So 34 choices left. Number of choices for the secretary's position is 33 because 2 people are chosen here. So in all, total number of ways is 35 times 34 times 33. 39,270. How many itineraries are possible if I am to travel Athens, Barcelona, Chicago, Delhi, El Paso, and Florence? So 1, 2, 3, 4, 5, and 6. If I am to travel Athens and Barcelona, one after the other, always Athens before Barcelona. And I do not visit any city twice. Now you see, this is not a straightforward question, right? Well, first of all, let's get to travel to all these 6 places. Okay, and I do not visit any city twice. First city, I have 6 options. Second city, I have 5 options. Third city, 4. Fourth city, 3. Fifth city, 2. And sixth city, I am left with exactly 1 option. Okay, so total number of itineraries is 6 times 5 times 4 times 2 times 1, that is 720. Now, you notice half these itineraries will have Athens before Barcelona and the other half will have Barcelona before Athens. So I need only Athens before Barcelona. So total number of itineraries is equal 720 over 2, that is 360. All right. Combinations. An R combination of elements of a set is an unordered selection of R elements from a set of N elements. So that's the difference between permutation and combination. In a permutation, order is important. In a combination, order is not important. So you're looking for unordered selection. An R combination is simply a subset. Subset because order is not important of cardinality R. For example, how many 3-member committees can be formed from a department of 35 members? Well, 3-member committees, it is 32 choose 3. 35 choose 3. 35 choose 3 is 35 factorial over 32 factorial times 3 factorial. Okay. Number of permutations divided by 3 factorial. So that's 6,545. So whenever order is not important, you are taking combination. Okay. The number of R combinations of a set with n distinct elements is denoted by C and R. Also denoted within parentheses n above R below. It is called binomial coefficient. The number of R combinations of a set with n elements where n is a non-negative integer and R is an integer where 0 to n equals C and R is n factorial over R factorial times n minus R factorial. So notice P and R is C and R times PRR. Look, PRR is R factorial. So if I multiply by R factorial, then all I'm left with is n factorial over n minus R factorial, which is P and R. So it's simply calculations. An immediate corollary, a result that follows, is choosing R from n minus from n elements is the same as choosing n minus R elements from n. That can be seen from this formula itself. Instead of R, if I have n minus R, that takes care of this, and n minus R takes care of this. Basically, what this is choosing R elements from n elements is as good as choosing n minus R elements from n elements. In how many ways can you draw 5 cards from a standard deck of cards? Well, standard deck of cards consists of 52 cards. I am drawing 5 cards. So that's 5. So 52 choose 5. So I am drawing 5 from 52. Order does not matter. By formula, it is 52 factorial over 52 minus 5, 47 factorial times 5 factorial. And that's your answer. 2,509,000. I'm lost. whatever. So this is comma here. Okay. So let's see. 98,000. So 202,598,960. All right. Now, how many ways can you choose 5 kids to play from a classroom of 20 kids? So I'm not asking them to stand in line. So order does not matter. So I'm choosing 5 from 20. That's simply a combination. 20 choose 5. I get 15,504. Definition: a combinatorial proof of an identity is a proof that uses counting arguments to prove that both sides of an identity count the same objects but in different ways. Or a proof that is based on showing that there is a bijection between sets of objects counted by the two sides of the identity. These two types of proofs are called double counting proofs and bijective proofs, respectively. Okay. How many bit strings of length n containing exactly r ones? Well, you want r ones from n choices. In other words, you want to choose r from n. That is, n choose r. Okay. Lastly, how many ways can you draw 5 cards from a standard deck of cards? If there are to be exactly 2 kings. You want exactly 2 kings. You're choosing 5, exactly 2 kings. Those 2 kings come out of 4 kings. So, and the remaining 3 cards come out of cards which are not kings. In all 4 kings and in all 48 cards which are not kings. So 2 from 4, those are the kings, 3 from the rest. So 4 choose 2 times 48 choose 3. It is 103,776. All right. That completes lesson 17. We'll continue in our next video, lesson 18.